Okay, so here's the example. Let's suppose I'm a seller. I am planning to sell my house and you're a buyer and you're willing to buy my house. Okay, so let's suppose my valuation for this house is $500, okay, or $500,000, but I'm going to ignore 1,000 just for simplicity. And then your valuation for the house is $600,000 or $600, again, for simplicity. Well, there's some assumptions which are critical. One of them is that, remember, these are not asking prices, all right? This is the the minimum amount of money I'm gonna accept to sell my house. If it is $500, that means I am not going to sell my house if somebody offers me a cent less than this amount, all right? Obviously, I will be happier if I can sell it at a higher price, but I will never accept a price lower than this. I rather prefer to keep my house instead of selling it at a lower price, all right? And willingness to buy is basically the maximum price you're willing to pay for this house. You want to pay, you will be happy to pay less than $600, obviously, but you don't want to pay a cent more than $600 because that's the top amount of money you are willing to pay. So this is important. Second thing, the second assumption is that these are common knowledge. All right, I know that this is your willingness to buy, and you know that this is my willingness to sell. Well, in reality, usually these info are not common knowledge, and in fact, this is an important part of negotiations, right? Strategically, it's usually not optimal to reveal your willingness to sell or your willingness to buy, because that would put you in a disadvantaged situation, so you shouldn't do that. But the thing is, if these are not common, if these information is not common knowledge, well, then that means this is an incomplete information game, and its analysis is totally a different story. And so, for simplicity, in this lecture, in this episode, and throughout the cooperative bargaining approach episodes, we're going to assume that all the information is common knowledge, all right? So in a sense, we're looking complete information games, all right? That's a very strong assumption, but again, it's kind of a first step to build up upon building a more complicated models. So under all these assumptions, so these two guys are going to negotiate and determine the price. Right? I mean, I know different countries have different methods. Some basically makes it more like an auction. It's like the seller announces the house and puts the house on a market, and then different sellers comes in, and then they submit their bids, and then the seller basically sells the house to the highest bidder. I know, but for simplicity, let's assume there's only one buyer available there. All right, and the willingness to buy, willingness to sell are common knowledge. And so how are they going to determine the price? Obviously, the government or Amazon is not going to determine the price. They're just going to negotiate about it. How are they going to negotiate? Is it going to be like Rubinstein's alternate? Well, how? I don't know. I mean, people negotiate in different ways, right? So this is totally up to them. But don't forget, in a cooperative, game theory approach, we don't want to model sort of the timing of or the strategies of the games, but rather is like build the model and then try to predict what good outcomes we could achieve out of that. All right, so this is exactly what we're going to do. So we're going to build the model first, and then in next episodes, we're going to talk about what good outcomes we can achieve out of that. Okay, so they're going to negotiate, but here's a very, very important point. They're going to negotiate about what? They're going to negotiate about price. So what should be the price? Well, obviously the price should be higher than or equal to 500 and should be less than or equal to 600. Well, why is that? Well, because look, if it is not in this range, the trade is not going to occur. All right? Well, fine then. So basically, I have the D, idea of D. No trade, right? I know it's not a payoff vector. I will make it a payoff vector in a moment, but at least conceptually, I know what D is in this framework. No trade. The buyer and seller cannot agree on this price. But in fact, there are like millions of different potential prices they could agree, right? But obviously, they may not. And so the no trade is a potential outcome of this negotiation. And it is the outside option or the disagreement point, okay? Well, again, depending on the story, you may change the disagreement point. Well, how so? Well, maybe these parties agree that if they cannot decide on the price, they're going to go to court, and then the court decide on the price. Well, normally this doesn't happen, right? I mean, court never determines price between buyer and seller. But I mean, for some, or maybe they're going to go to some sort of arbitrator or mediator, whatever, and so that party is going to determine for them. But again, they may sort of agree on this depending on the story, but usually they just don't do a trade and then they go to their separate ways. Okay? So, what else? Another very important point is the following. The agreement must be unanimous. What does that mean? That means nobody can enforce price to seller or price to buyer. They should both accept that price. All right? So, I mean, whatever the type of negotiation they do, let's say they come up with the price 550. Okay? Well, if one of the parties say, no, I don't accept that price, well, then they're not going to, I mean, there's not going to trade at that price. All right? I mean, no one, all right, no third party can enforce any price to the buyer and to the seller. So that's very important. And in fact, this is what happens in sort of standard negotiations, many standard negotiations, right? So these are very important implicit assumptions. We don't highlight again and again, but throughout those episodes, we're going to keep assuming these assumptions that unanimity is like everybody should agree on the price. Or, I'm sorry, the outcome. Okay, now we kind of sort of talked about what the disagreement point would be. Now let's try to create this payoff profiles or the feasible payoff profiles. Well, first off, what is the set of players? Well, it's this, right? There are two players. Okay, good. Well, what about the set S? What is it? Or what does it look like? Well, first, it's totally up to you, how you define it. But the thing is, for this game, I'm going to do it at least once. I'm going to define X, the set of outcomes. And then from that, I'm going to talk about S. What matters, as you will see in next episodes, is S. So X is basically a stepping stone. So set of outcomes. So what are the potential outcomes of this problem? Well, agreement and disagreement, right? Yeah, but I would like to achieve the set S, all right? And so the thing is, so this is, remember, the payoff profile. So is how much utility they're going to get from every single alternative or every single outcome. So from X to this set S, I need to basically talk about utilities, all right? But here it's just outcomes. But outcomes, the utilities are defined over outcomes. But what is really the outcome? Is it the price? So what are those players get utility from? Is it the price? Not directly. I mean, they don't really care about, I didn't specify that, but they don't really care about price per se. What they care about is the following, the surplus. Oops. Right? Well, what is surplus? The buyer's surplus is basically his willingness to pay, maximum willingness to pay, minus the price he pays. So the difference between these two is his surplus. All right? And what about the seller? The seller's surplus is the price he receives minus the maximum willingness to sell. All right? So that means if they agree on price, for example, 500, okay? Well, it means the buyer is going to get a surplus of 100, the entire surplus, and the seller is going to get 0 surplus, okay? Well, why is that so? Well, I mean, think it this way, the surplus is like, I wanted to sell this house, but the 500 was my minimum point, right? I was kind of indifferent between selling and not selling. If the price is 500, I'm gonna sell it anyway, but I'm indifferent between selling and not selling. All right, like 500 is like my 0 utility level, kind of. All right, the surplus is 0. So if the price is actually 0, well then, again, my kind of utility or surplus is 0. You see what I mean? So that's sort of the intuition. However, the buyer is going to be extremely happy if the price is 500. Why is that so? Well, because this is actually the lowest price he could achieve in this negotiation, right? And basically he gets the entire surplus. So all we care is not really the price per se, but the surplus each player gets. So therefore, how do we define the outcome? Well, we define the outcome by, I don't know how to denote it, but let's denote it. Oh, by the way, here, as we just argued, the price can be 600 or less than 500. So therefore, we can define this as the set of outcomes as follows. Let's do it this way. P such that P is in 500, 600. Okay? Again, I mean, you may want to define set of outcomes in a different way in terms of sort of your utilities, but we're not there yet. So now I would like to talk about sort of set of feasible payoffs. Well, here, oh, by the way, in the set of sort of outcomes, does this include the D? Well, remember D was what? The no trade. Well, the no trade case here means what? So the no trade here means that there's no surplus achieved by any of those players. All right, so basically a 0-0 is a no, so D, which is 0-0, meaning nobody receives any surplus. So that's one potential alternative. It's feasible, and it basically indicates that there's no trade between this buyer and the seller. All right, so now I'm going to come to the feasible payoff profiles. Well, now I need to sort of specify what the utilities are. Well, for simplicity in this example, I'm going to assume that players are risk neutral. All right. Later, I am going to give some other examples where we talk about risk averse, for example, negotiators. But when the agents are risk neutral, well, that means what? If I receive a payoff, a surplus of 100, it means 100 utility level. All right. If the surplus is 500, well, then my utility is also 500. All right, so basically U of X is equal to X, to be specific. And so here X is the surplus. I'm sorry for keep using the same notation for representing different things. I'm sorry. But I hope it is clear what I mean X here and what I meant X there. All right, so that means the utility functions for the buyer and the seller, which is kind of the standard utility functions in those type of problems, in economics at least, UB and US, which is a function of price, obviously. So the buyer's utility is literally his surplus, VB minus P, and the seller's utility is again his surplus, P minus VS. So therefore, the set of feasible payoffs is, let's denote it as follows: x1, x2, right? Because there are two guys in our square, such that x1 plus x2 is less than or equal to 100. Why? Well, because remember, this is the total surplus they could get. So all those payoffs are feasible. Well, you may say, how come? I mean, I understand 0, 0. So 0, 0 is in here. Okay. I understand, for example, they share the surplus like 50-50, or one guy gets the whole surplus, the other guy gets the zero surplus. Meaning, I understand x1 plus x2 equals 100. But what the heck does that mean, x1 plus x2 is less than 100? So think it this way. Maybe these guys are going to negotiate, and then they're not going to make sort of a decision, and they're going to go to another, third party, and then this third party is going to listen to each side, and then he's going to make a recommendation price. But this third party, because he's not sort of doing this for free, he's going to charge some fee. And so what does that mean? That means although this recommender, the third neutral party, determines some price, the surplus the buyer and the seller is going to get is not going to be VB minus P, P minus VS. But the thing is, they also have to pay fee to this third party. You see what I mean? So basically, they may kind of decrease the surplus they could share between each other and sort of kind of waste it away. Right? That's one sort of interpretation why we might have x1 plus x2 strictly less than 100. Another, maybe remember the Rubinstein's alternating offer bargaining game. There was a time discount. They were discounting time, and time is important because everybody wants to get an agreement immediately, and delay is costly. So maybe, again, for these guys, the buyer and the seller, they're going to negotiate over a month. And 1 month maybe is very costly for both because the buyer is actually renting an apartment, and a monthly rent he has to pay if this negotiation takes longer than a month. Or same for the seller, he has to pay his mortgage or whatever fees it's due. So whatever the reason is, if the negotiation takes longer, and then you see what I mean? The amount of surplus they are going to receive could be less than VB minus P and P minus VS, or the sum of their surplus may be strictly less than 100. Again, we do not model the bargaining game or the bargaining. Remember, the cooperative game theory is leaving everything as a black box. What I mean by writing this inequality is that this black box could actually lead to some inefficient outcomes. We haven't defined it yet, but we know what it means, efficient outcomes in this type of environment. x1 plus x2 equals 100 is the efficient outcome. So anything less than 100, adding up less than 100 is not efficient, but again, it might be a potentially feasible outcome. So this is how we define the set S in this specific example. So, to be more specific, this S, comma, 0, 0, or just sometimes we call it zero vector, all right? So this is not zero number, but zero vector. Usually we make it bold, but I can't do it here. So this represents this bargaining problem, okay? So this is how we transform each bargaining problem into a more mathematical or sort of a mathematical object, including S, including 0, 0. Obviously, you may wonder, is this really a convex set, closed set, bounded set? Well, yes, it is. Oh, by the way, I forgot to say this, but x1 and x2 shouldn't be negative. I mean, this is assumption, right? I mean, yes, they may negotiate so terribly, and so they may actually end up something negative. It's possible, so you may actually not you don't have to do this, but let's suppose that, as an outcome of this negotiation game, they will never suffer negative surplus or utilities, so to speak. Okay, so this is basically how much utility player negotiator 1 is going to get, and this is the utility of negotiator 2. All right, so remember x1 plus x200 means, so this is the maximum utility player 1 get, maximum utility player 2 get, and this is x1 plus x2, and everything less than that, but everything non-negative. So this is the set S, and this 0, 0 point is the disagreement point. And yes, this is a bounded set. The boundaries are obvious. It is a closed set, all right, because boundaries are included in this set, and it's a convex set. So therefore, and obviously there is, millions of x's which are strictly better than the disagreement point. And hence, this is in fact a cooperative bargaining problem.